Hey yo, so in this video I'm going to show you how I would go about making an async ambient system using Unreal 5's audio gameplay volumes. The system that I've made covers ambience, reverb, occlusion and spawning emitters asynchronously. So the first thing I'm going to go into is audio gameplay volumes. Audio gameplay volumes are the next generation approach to audio volumes for Unreal. They allow for more modular functionality while also removing collision tests from the game thread and moving them to the audio thread. So you can extend systems without having to worry about thread safety. Okay, so gameplay volumes. Audio gameplay volume. So you just add them like you would an audio volume, drag and drop them in the level and shape them accordingly. So there are multiple ways to adding functionality to the gameplay volume, but I'll show you how I would do it. So I do it through actor components. Well, that's how you do it, but I do them through bespoke actor components. So we do blueprint class and we do audio gameplay volume. And we want to add a audio gameplay volume component base. And I'll just show you that here. And we want to implement these events. So on listener enter and on listener exit, and that just triggers when the listener enters into the audio volumes. And then we want to do stuff. So yeah, I'll show you one that I've made earlier. So this is to do with creating bespoke ambient systems. So we use the audio volume like a room, or we can use them like doors. So we'd have to have two, one enter and one exit. And we use these functions here. So ambience enter. And all this function does is when the listener enters into the audio volume, we're going to grab the ambient manager and we're going to tell it some stuff. We're going to tell it what reverb would we like. So we have an E number here and we have a selection of reverbs. I don't know if you can see most of them. There's also a do nothing at the bottom. The same with the ambient area. What ambient area would you like to play? We have multiple there, do nothing. And how would you like to fade? How long would you like to fade in between these ambiances? Do we have any reverb settings that we'd like to change? Do you want to apply a filter to the ambience? And are there any emitters that you would like to load in? And that's really it. And the same goes for exit, but it is the reverse. So it's obviously the same at the start. We grab it, we grab the ambient manager, we tell it some information, but do we want to deactivate or unload the emitters within that area? And that's really it for audio volumes. I think it'll make more sense once I explain the ambient manager, which I'll just do next. So the ambient manager has four things going on. It has applying new sound effects, applying a reverb, applying occlusion settings, and applying a filter to the meta sound source. So when the manager receives a trigger from a appropriate gameplay volume, it will say, okay, do I need to apply a new reverb? If so, override the reverb submix with a new reverb setting. In this ambient manager, I'm using IRs, so impulse responses for the effects. It will then say, do we need to apply new sound effects to this area? If we do need to apply new sound effects, let's load them in. It will then see if we need to apply different occlusion settings to emitters, and then it will determine whether or not a filter needs to be applied to the meta sound source. So when a new area is selected or entered where you need to apply new sound effects, all this function is doing is making sure that we're not fading things in and fading things out when they're already fading things in. So it's just a little quality assurance thing. Then we async load that asset, and then we apply a fade to the previous meta sound source. And then we're going to watch some outputs on that meta sound source, which I will go into more detail in the meta sound section. So once this ambient manager is created, I'll then create children of that ambient manager and apply settings to it. So you can have different settings or different ambient managers for different levels. So this one has just 2 applied to it, and then we can change the reverb settings. So we're not having to change reverbs on each audio volume. We're just changing them in a child of the ambient manager for that particular level. And the same goes for attenuations or occlusion settings that you might want to change, and the fade on that level. So you can change how long it takes to fade between different ambient sounds. And that's really it for the ambient manager. So next I'll move on to the meta sound source. I'm going to go into a really high level explanation of this meta sound. It consists of 2 ambient beds and 5 one-shot layers. Now if there are no sounds in the associated layers array, none of the processing will be done for that layer. So in addition to that, there are 2 filters, one filter which covers one of the ambient beds and another filter which covers the whole soundscape. So I'll give this a little play and we'll listen to it together, and then I'll explain things in a bit more detail. So this design is like a sort of 70s computer room with war going on outside. Okay. Okay, so we have the 2 ambient beds. One of the ambient bed is covered by a filter. Now these ambient beds are offset in length to get as much bang for your buck. So the reason why I have a filter on one of the beds, or the option to filter one of the beds, is that, say for example that we are inside here and we want the ambience to reflect outside and inside simultaneously. We just want one of the ambient beds to be low pass filtered to give that character. And when we're outside, we want to have 2 ambient beds so that it's forever evolving. You can't catch the loop out. The reason why there is another filter on the whole soundscape is because if we say enter this area here, that we only really want the outside soundscape filtered slightly. So I hope that makes sense in terms of the options for filtering there. Next is the one-shots. So the one-shots are all played randomly in time, so you get little clusters of sound. In addition to that, they are working on full attenuation. So they are attenuated in rotation and attenuated in distance. Whereas the beds, they are not attenuated in distance. So when the meta sound spawns, you don't get the volume reducing as you move away from it. But there is rotation, so azimuth rotation. When the player moves, the beds move as well. So I'll go into a bit more detail why that is in explaining the outputs. So the outputs we are watching are when the attenuation is surpassed, and also when clusters of one-shots stop playing. So I'll return to the ambient manager and explain that now. Okay, just returning to the ambient manager to explain why we're watching the outputs on the meta sound source. So the reason is that we want to move the meta sound source when there are no one-shots playing. So the outputs we are watching are when there are no one-shots playing, or when the attenuation is surpassed. And when those conditions are met, either of them, we move the meta sound source to a different location within a certain range from the player. And what that does is that it provides depth to the one-shots. So for example, we have a cluster of one-shots, little analog bleeps playing, and when that cluster is finished, then we move the meta sound source to over here, or behind the player, or wherever, as long as it's within a certain range. Or when the attenuation is surpassed, so if the attenuation range is 4000, that when that range is surpassed, that we respawn the emitter, well, not respawn it, just move it within a certain range, so say 2000 units. And that provides depth to the mix while containing it within one voice, so you're only using one voice rather than using like multiple voices for just little sounds. But next I'll go into explaining how you could asynchronously spawn emitters that aren't associated with the meta sound source. last but not least is asynchronously loading emitters or sounds using audio gameplay volumes. So in this level, we have a wind spline up here, and we have an air vent loop there, and we have 2 light buzzes in here, and some intermittent groaning there and up there. So I don't want all those sounds to be loaded at once or to be virtualized. It just doesn't need to be that. So using audio gameplay volumes, we want to async load those sounds or those assets in. And because they're such small file sizes that we can load them in quickly, nobody's going to notice. So to do that, we're going to return to this audio gameplay component here. And if you noticed on the Ambience enter, we have a function at the end called emitters to activate. To activate emitters, we're going to have 2 arrays, one to activate, one to deactivate. They are actor arrays, and we're also going to use a blueprint interface which has 2 functions, a load emitter message and a stop emitter message. And as you saw in this function, we're just going to loop through the actors, and then we're going to send them the message to load or stop. And in the component here, you can select the actors you want to activate and deactivate. So you can load them in or load them out when needed. And I'll just show you in the emitter. This is just a really simple example of how to start the emitter using the blueprint interface. So yeah, pretty simple stuff. Is that you receive event, and then you load in the sound, and then you fade it in, and then for stop, you fade it out. And that's it, really. I mean, you can also do the same thing for a spline. So you're only starting the spline's processing when you load it in, right? So when you're in that area, that you then start your spline process. That's not it. But yeah. I don't think there's much else I can show you on that, but that's the gist of it. So I hope that video helps you understand how I would approach creating an ambient system, but also shows how you can use audio gameplay volumes to create bespoke systems in a modular way, where you're only using the bits that you need. Okay, cool. Thanks for watching. Hope that helps.